G'day, welcome to the Tech Math channel. What we're going to be having a look at in this video is 3, 4, 5 triangles, which uses some ideas from Pythagoras' theorem. This is a really handy little thing to know for things like building, mainly when you want to put in walls, things like this, and you want them to come out at angles 90 degrees, really nice and square. So I'll start out by drawing a 3, 4, 5 triangle. So this is a 3, 4, 5 triangle you're going to see. It's a triangle that has a side length of 3 units, a side length of 4 units, and a side length of 5 units along the side here. Also between the two shorter sides, the 3 and the 4 unit sides, we have a 90-degree angle. And this is the part that makes it really handy for squaring up a building and making a wall come out exactly 90 degrees. So how would you go about using one of these? Well, if I wanted to actually make a wall that came out exactly 90 degrees, I would do the following. So at the moment, you'd have this existing wall, which would be occurring along here. Okay? So from the particular point where you wanted this wall to come out 90 degrees, you would measure 4 units up. So whether that be 4 feet or 4 meters, depending on where you are, you would measure this 4 units up to this particular point here. And you might put a little mark there or a nail or something like that. From this particular point now where you actually wanted your wall to come out from, so this is the existing wall, you want a wall to come out from here. You could measure 3 units, okay? And that's along here. And you'd roughly try to do it around about 90 degrees. And out here, you'd have your 3 meter mark, okay? Now, at the point where this hit exactly 90 degrees, where this was exactly 90 degrees, the point between this part here, where you've measured 4 meters, and this part here, where the 3 meters comes out, should be exactly 5 meters. And so you'd have to stuff around a little bit and maybe move this back and forth. But as you did that, you would eventually hit a point with this where the distance between this became 5 meters. And when you did, this here would be exactly 90 degrees. And that's how a 3, 4, 5 triangle works, and will help you actually put in a 90-degree wall. So what's going on here? Well, for any right-angle triangle, the side lengths can be worked out using Pythagoras' theorem, and I'll show you how this works. Pythagoras' theorem states the following, that a squared plus b squared is equal to c squared. What does that mean? Well, A and B are the two shorter sides, and it's basically saying if you square one of the shorter sides and add it to the square of the other shorter side, well, the result will be the same as the square of the diagonal here. So let's try that out. We'll put A here, we'll put B here, we'll put C here. All right, so let's give it a go. All right, so A here is 4, so 4 squared, plus b squared, which is 3 squared, should be equal to 5 squared, if Pythagoras' theorem is working, and you know it's going to, right? Otherwise I wouldn't be telling you. So 4 squared means 4 times 4. 4 times 4 is 16. 3 squared is 3 times 3. 3 times 3 is equal to 9. And this is equal to 5 squared. 5 squared, 5 times 5 is 25. So 16 plus 9 is equal to 25. And that's true. 16 plus 9 is 25. Pythagoras' theorem is proven on this particular 3, 4, 5 triangle here. Okay, so why is this so important? Well, just pretend that you were doing this on a bigger building. Okay, to see why this is so important is a lot easier on a bigger sort of room here. So say we had a 10 meter by 10 meter room that we're putting on. We have this wall and we want to come out 90 degrees and make everything good and square. So we have 10 meters here and we could actually square up using a 3, 4, 5 triangle. Okay, so once again, what we could do is we would have 4 meters here and we would measure out 3 meters and we would end up with this side here that should be 5 meters. Okay, so this should be 3, 4, and 5. And this here should be 90 degrees. But say we were a little bit inaccurate and we didn't actually do our squaring up as good as we could. And instead of actually making this 90 degrees, we made it 89 degrees. We're 1 degree out. How much do you think actually this would throw you over the course of 10 meters? It would actually, obviously, you know, it would slowly come out a bit, but how much would it come out? And you may be surprised with this, but I've worked it out a little bit earlier, that the actual difference that you would actually get from that particular error, if you did 89 degrees and didn't square up properly, would be around about 17.5 centimeters, 174 mil to be more precise. Okay, so it's a really important thing that you do to go through and actually get these right. This is a huge difference, right? Not only will it cost you a heap of money if you do this, but it's also going to provide you endless aggravation as floors don't look right and walls don't fit properly and tiles maybe don't go very well. Look, you know what? It's just really good that you would go through and make sure this is 90 degrees and get it exact. Okay, so it's important that you spend the time and do that. So anyway, how could you go about and even make that a little bit better? So if we wanted to square up this 10 by 10 metre room, what we could actually do to make it even more exact and not go out that particular amount here would be we could use Pythagoras' theorem once again. We know that a squared plus b squared is equal to c squared. Our two shorter sides are a and b. Because we want this 90-degree angle here, the diagonal is going to be just here. This is going to be c. So we could work out what that particular size is. Okay, so what would it be? Right, so we have a, which is 10 squared, plus b squared, which is also 10 squared, is equal to c squared. We don't know what that is yet. All right, 10 squared, 10 times 10 is 100, plus 10 by 10, which is 100, is equal to c squared. So what does c squared equal? Well, c squared is equal to 100 plus 100. 100 plus 100 is 200. So c is going to equal the square root of 200. The square root of 200 is 14.142 metres, which is equal to 14,142 millimetres. You could supplement a similar sort of thing if you were using feet and inches there. So this particular side here, if this is 10 and this is 10, would be 14.142 metres. Okay, and you could actually get out your tape measure. You could measure up 10 there. You could measure out 10 there. And when it's 90 degrees exactly here, this should be 14 metres, 142 millimetres, or 14,142 millimetres. So for more practice on these, I'll put up a link to questions I already have on Pythagoras' theorem. It's a really, really handy thing if you're working in the construction industry, or even if you're doing something like this at home. I've used it myself, okay? It's a great way of squaring up. And I'll tell you, the maths that you do here will save you so much anger later if you don't do it. You do not want to be at 90 degrees, okay? Anyway, so that link will go up there. If you like the video, please remember, like and subscribe to the Tech Math channel. Thanks for watching. We'll see you next time. Bye.